Right, so let's try to find the point where the shear force equal to 0. So to do that, we can refer back to our free body diagram with the known reactions. Then we just take a section between point A and C, and as it is, we know it's x, but we don't know what x stands for. So taking it from here, so we can say that x starts from this point. It starts from here to say x. We don't know the distance, so let's call it x. So we could draw that section this way. We have this reaction here, 23 kilonewtons, and this is what, well, we've taken the section and we're saying that the distance is what, x, and this UDL is what, 10 kilonewton per meter, and point C would have been somewhere here, C. Okay, it's not of interest to us. Okay, so our interest is to know the value of x. So looking at this, we have the reaction 23 kilonewton here, the UDL here. Then we are saying that the shear force here is equal to 0. So we can start from that premise. That's our shear force at point X equal to 0. So let's get an expression for that shear force. So looking at this, when we stand here, then we look to the left. We could just sum the forces, to the left of that point, and those forces would have been the shear force at this point. Okay, so let's call it, so we're saying that at x, so let's call that point maybe fx, or the shear force at that point, fx. So to the left, so fx would have been what, our first force here. So it means that we're holding somewhere here. So it means that we have this force going up or shearing the beam up. So that's a positive shear force, positive. And then we have this UDL, and that one is pointing towards the negative axis. So that's negative shear force. So we have negative UDL, and UDL, we said always you multiply it by the span. So you have negative 10 times the span. The span is what? A to point, this is what, x. So we have 10 times x. And again, yeah, so that's it. These are the two forces that we have. We have the reaction, we have the UDL. We are equating this to what? Okay, that's okay for now. We're saying that at that place where the shear force crosses the 0 line, sorry, at the point where we have x, we're saying that that's where we have shear force equal to 0. So we are simply saying that fx equal to what? 0. Fx equal to 0. So if fx is equal to 0, we have what? 23 minus 10x equal to 0. So this would give us x equal to what? 2.3 meters. So what it means is that at the point where the shear force equal to 0 in the shear force diagram is equal to what? 2.3 meters.